Okay, we have been talking about rational numbers, and if you remember, a rational number is a number that can be written as a fraction, right? There's a few things then that I want to go over with you in regards to how we do operations with fractions, okay? So if we are adding, subtracting, the one thing that we need is a common denominator. I can't add or subtract without it. Denominator. So, for example, if I have 2/5 plus, let's go 7/10. Okay, I can't add these together as is. I need to find a common denominator. So if I look at 5 and 10, well, I can look and see 10 is going to be a common denominator for both, right? How do I get from 5 to 10? Well, I multiply by 2, which means that I also need to multiply the top by 2. So this is going to be the same as 4 over 10 plus 7 over 10, which is going to give me 11 over 10, right? I can just leave it in this form, 11 over 10. I know that that maybe feels weird for you, but you can just leave it. Otherwise, if you remember how we get a mixed number, I would take 11 divided by 10. Okay, I know 10 goes into 11 once. When I do that, I'm left with 1.
Mrs. Chris, you have a call on line 1. Mrs. Chris, line 1, please.
Okay, when I divide, I am left with 1/10. So this is the same as 1 and 1/10. Okay. This would be the same if I were subtracting. So I could do like 5/6 minus 5 over 18, something like that. If I wanted to do this, to get from 6 to 18, I would multiply this by 3, which means I have to multiply the top by 3, which means I've got 15 over 18 minus 5 over 18 gives me 10 over 18, but I can simplify this, so I'm going to. So I can simplify this down to 5/6. Oh no, 5/9. That is my answer, okay? If I'm adding or subtracting, I need to have a common denominator. If I am dividing, actually let's do multiplying first. If I multiply fractions, all I need to do is multiply straight across. This is pretty straightforward, right? So I could have 1/3 times 2/5, and I just multiply straight across is the same as equals 2/15. Done. I just multiply straight across on the top and the bottom. Okay, and then that's the same. I could have 5/3 times, let's do 9 halves, okay? Something that I can do when I'm multiplying fractions like this is I can look at what's across from each other, right? And I can simplify. So when I look at this, I see 3 and a 9. Well, I know that 3 goes into 3 one time. 3 goes into 9 3 times. So I can make this 5 over 1 times 3 over 2. So then I can just multiply across, gives me 15 over 2. Right, I can cross simplify if I see some common things. The last one then that we need to go over is dividing. There's two ways that we can divide fractions. Okay, way number one is a common denominator. Then I can just divide across. So, if I had 3/10 divided by 1/10, I can just divide straight across because I have a common denominator, so this is just going to be 3 over 1, which is 3. If I had, let's say, let's do 1/6 divided by 5/12, something like that. I could use a common denominator to do this, and I would multiply this by 2, which means I have to multiply the top by 2. Gives me 2/12 divided by 5/12. Then I can just divide straight across, gives me 2/5. And the reason that I can divide straight across, so this might be, you might think like, why am I getting rid of the 12 or the 10? We can think about this. 10 divided by 10 is 1. So this 3 is actually a 3 over 1. Same thing down here. 12 divided by 12 is a 1. So if I were to write this the way that we would think to, it would be 2/5 over 1, right? But anything divided by 1 is just itself, right? So I don't need to have this over 1 part in order for it to be correct. So I can just leave it like this. So I can find a common denominator and divide across. The last way that we can divide fractions, or the other way we can divide fractions, I'm sure you've heard of, is keep, change, flip. So our second way, I'm going to say use the reciprocal. Reciprocal. So, if I had like 1/3, 1/3 divided by 1/5, what my keep, change, flip says is I keep my first one, change my sign, and I flip my second one. So this would be 1/3 times 5 over 1, which is equal to 5/3, right? I want to give you a little clue into why this works. So I've been explaining as we go, like if I just divide across, it's the same thing as it being over 1. So there's a reason why the reciprocal works. So let's use an example like 3 over 4 divided by 5 over 7. Let's just try that. Okay, if I were to write this as a fraction, I could write this way. 3 over 4 divided by 5 over 7. Do you want to solve a problem like this? If I were to just leave it like this, does that look like a fun thing to solve? No, it does not. Okay, and so what I want to try to do is to get a 1 on the bottom. So if we think about, like here's a good example, the number 5, right, can also be written as 5 over 1. So anything over 1 is just itself. So if I can get this bottom part to equal 1, then I only have to worry about my numerator and I don't have to worry about my denominator. So my denominator in this case is 5/7. This is my denominator. and I want it to equal 1. So 5/7 times what is going to equal 1? Well, this is where a reciprocal comes into play, right? So I've got 5/7 times 7/5. These cancel out, right? Just gives me 1. So I can come over here and I'm going to get rid of this circle here. Okay. I can multiply this bottom by 7/5. But if I multiply the bottom by 7/5, I also need to multiply the top by 7/5. So now I've got 7/5 over 7/5. If I had this as a fraction, this just equals 1. Right? So I'm essentially multiplying my division problem by 1. So now I've got 5/7 times 7/5 on the bottom, which I know equals 1. So then I'm just left with 5/4, or 3/4, sorry, that looked like a 5. That's my own fault. Oops. We'll just do this. I've got 3/4 times 7/5, which is going to give me 21/20. I'm just going to multiply across now. (21/20). Okay, so I've got 21/20. So what this means then is when I do my keep, change, flip, so keep my first one, change my sign, multiply by my reciprocal, this is actually what's happening. This is actually what's going on, is I'm doing all this extra steps without even realizing it, right? So if I had this, my 21/20 divided by 1, then I just have 21/20, okay? So keep, change, flip is probably one of the fastest ways to divide fractions, and now you know why it works.